Hey guys, I just want to let you know, I just made this video. I forgot to turn on the mic. So I'm really going to push through this. There's going to be a million mistakes. I apologize already. Alright, we're going to start talking about solving systems of equations. There are three different ways that we can solve a system. Today we're going to start talking by using a graph. Right here, I have a cool little example of what a system looks like. You can see that it's two different equations, and we are dealing with x and y in these equations. Our goal at the end is to try to solve for x and y that it satisfies both of them. So the solution of a system of linear equations is an ordered pair. And this ordered pair, when substituted back in, satisfies each equation in the system. So at the end, your answer should look like x comma y, and when we substitute it back in, both sides are equal to each other. Now we are solving this using a graph. When using a graph, the solution to a system is where the two lines intersect. So it's where they cross one another. Below, I have two examples of systems and their graphs. I just want us to look at them, use the graph to solve, and then check our solutions algebraically. So for the first one, I have 3x plus 2y is equal to 4, and negative x plus 3y is equal to negative 5. On this graph, we have to see, okay, where do they intersect one another? That's right there. At the coordinate point, negative 2, comma, negative 1. So to check it, we're going to substitute it back in to make sure that it satisfies both ends. So I have 3 times x, or 2, plus 2 times y, or negative 1. Does that equal to 4? Let's see here. I have 6 plus 2, or negative 2. That equals 4. Yeah, that one checks out. And then for the second one, I have negative x, or negative 2, plus 3 times y, or negative 1. Does that equal to negative 5? 3 times negative 1 is negative 3, plus negative 2. Yeah, she checks out. Looking at the second one here. Oh, real quick, hold on. Put a negative sign here. Somebody messed up the notes. I'm not going to say who. All right, where do the two lines intersect one another? Right here at the corner point, 3 comma negative 3. Substituting it back in, I have negative 3 times 3 plus negative 3. Does that equal to negative 12? Yes, it does. And I have 2 times x, or 3, plus y, which is negative 3, equals 3. Does that check out? Yes, it does. So we're just looking at where the two lines intersect one another. I wrote it out in 4 steps. Step number 1, write each equation in slope-intercept form. Or y equals mx plus b. Once you have them in slope-intercept form, you can go ahead now graph those two equations. After you've graphed them, look to see where the point of intersection is. Then you can check the coordinates algebraically by substituting into each equation of the original linear system. Make sure you substitute it back into the original problem, not where you wrote it in slope-intercept form. So I have 2 cool examples here for us. We want to solve these systems graphically, and then check our solutions algebraically. So I'm going to take each equation and write them in slope-intercept form. So for this first one, I will subtract x from both sides. Y is equal to negative x minus 2. And then for the second one, here she is. I'll start off by subtracting x from both sides, 2x's to be more exact. And then divide both sides by negative 3. You should get that y equals to 2/3 x plus 3. Now that they're written in slope-intercept form, I can go ahead and start graphing them. For my first line, I know that my slope is negative 1 and my y-intercept is negative 2. So starting at negative 2, I'll go down 1 over 1. I like to put a lot of points because I can't draw real straight. That's more than enough dots. Oh my goodness, look how perfect that line is. And then for the second one, I know that my slope is 2/3, and my y-intercept is 3. I have to go up 2 over 3, or down 2 over 3. Bop. There she is. Oh no, but where do they cross or intersect one another? Boom, right there. At -3, 1. However, I could have messed up somewhere, so let's check it algebraically by substituting it back into the originals. The first one is x plus y equals -2. So I'll check -3 plus 1. Does that equal -2? Yes, it does. And for the second one, I have 2 times -3 minus 3 times 1. Does that equal to -9? Yes, it does. Write them in slope-intercept form, graph them, see where they intersect. Okay. For this next one, I want you to pause the video and then just write these two equations in slope-intercept form. When you wrote them in slope-intercept form, you can unpause and you can compare what I have. So pause it now. Really hope you paused it because I'm giving the answer now. That's y equals 2x plus 2 for the first one, and y equals -x minus 1 for the second one. Now that you have your equations written in slope-intercept form, go ahead and pause the video again and graph them so you can compare it to what I have. So pause it now and graph your equations. Again, if you did not pause it, I'm gonna be so mad. I won't know, but I will know. Your parents will tell me. There's the first graph. And there's the second line. Write what the solution is here. You should have said -1, 0. Now let's substitute it back in, check to make sure that this is the correct answer. I'd have -2 times -1 plus 0. Does that equal to 2? Yes, it does. And for the second one, I'd have -1 plus 0 is equal to -1. That also checks out. This is the correct answer. Hooray. It's glowing. All right. Tomorrow, we're going to be dealing more with solving systems using a graph. If you have any questions, please let me know.